Hello and welcome to GM-BIST construction. Today we are going to learn how to carry out our structural analysis. We import our DWG drawings to our Protastructure and we begin the analysis, the modeling and the analysis. So this is what we have. We have the ground floor and the first floor. So we first of all import our ground floor. We'll just highlight it, type W, enter, and I will save it. Let me save it in my document as class 1. Change it to DXFI, then you save. So this will be in millimeters. Okay, the drawing is saved. So the next thing I do is to load my Protastructure 2021. So we'll now open new project, type project name class 1, choose your code BX8110. So the next thing you do is to import your DXFI. So come to add. So this is our class 1. Open. So we are not importing our grid lines, we are not importing our columns. So we just click OK. So we have our DXFI here. So the next thing we go to modeling. The modeling, click on your grid. So from the architectural plan, you have 1 here, so I will not change it. The label of the axis, start with 1. The next one will be 2. So let me jump 3 to 4. 4, 5, 6. Then the next one is 7. 7. You can actually import your grid lines and your columns. So I will now change to the x-axis now. So this is A. This is D. This is F. So I need a column at this point. What I'm going to do is, let me check out the distance. I'll come to this intersection. So I have about 8.73 meters. So what I'll do is to offset this. I'll offset. So Control F2 minus, say 4.2. So this, I will now change this one to be my F prime. F prime. Okay. So let me start inserting my columns now. The size of my wall, I can actually measure it from here. Size 230. So I'll have my size of my column to be 230. Right, 230. This one's 230. Like 230. So I want it to be centralized. have it at the intersection where I want my columns to be. This place and here, then at this place and here again, here, okay, here, so I think I need a grid line at this place. Okay. I use the property of this, then I click on C, I change it to C. So I need a grid line here. See? So okay. Introduce my column here. So now I want to check the span here, so I know the type of column I introduce. So we have 12.23. So I'll have to introduce my columns at the center, but we'll have a target so that I don't have much columns in my design. So let me introduce a column. Let me introduce a grid line here, or let me measure. This 5.27. So from here to this side, 6 again. So I can decide to take this as my center. So I will introduce this grid line. Introduce this grid line. All of this can actually be done in AutoCAD. Well, general arrangements. I will change the size of my columns now. I have 230 by 450. So let me edit this. So I can actually edit it so that the column doesn't extrude this way.
Architect. Engineer. You are creating another video.
So you now insert your columns. So at this place now I have a window here, but we need this to be at the center. So I can actually put my column here, then get back to the architect, and I'll try to identify the center here again. So I can actually use my grid line again to identify the center from there to here, 13. So I will actually offset this thing to be 6 points. I will offset G to be 6 points. Let's say 1.5. So D, Control F2, 6, 150. D, Control F2, minus 6, 150. So this is what I have. Well, this will be, let me edit it, F prime. So I will be able to, let me use circular column for this place. Click on modeling, click on column, go to column editor, click circular. So let me use 350. Let's see. So I can introduce my I'll centralize it. So let me begin by inserting my beans now. So the width of my bean will be 230, the depth 450.
Are you late?
No. Okay. Let me introduce a column here. This is what we have. I'll also join this. So for this we have about 6 meters. So what I will do, I will change the width of the depth of my beam to be 600. So this is what we have. Let me introduce this pin here. So we are done with fixing our beans. Now we go to our slab. We edit our slab. The depth of our slab will be 150, the cover 25. That way the dead load, you can choose a value here, which we are dealing with room and imposed load for general domestic use. Okay. I have to introduce my bin at this place because we have a staircase there, and not here because we have our landing. So I have to introduce a grid line. I'll set this here. So for this, I will change the depth of my slab to be 175. 175. 175. Then the next thing we do is to edit our wall unit load. Edit wall unit load. A width of our Nigeria block 3.47. The wall height. Normally the wall height is a height from the ground level to your soffit, or let me say to your slab. So if you have a slab, let's say you have 3.45 as your height of your ground floor, let's say from your foundation, from your floor level to your slab. And for you to get your wall height, you now minus by the depth of the beam, because the depth of the beam is inclusive as the height. Now you see minus 450, get 3 meters. Now if you're using a height of your beam depth of 600, I just say 450 minus 600. So this will be the wall height for your building. So for in this case we will use 3.0 because everything is in meters. Then the thickness of your wall in meter will be 0.23. Then you copy your wall unit load. Then you highlight everything, Control V. Then you click yes. So you are done with that. The next thing you do is to use your slab strip, your x-axis. Now you control, click on control so that you have a straight. Okay, sorry, let us edit our materials. Click on analysis, go to building analysis, parameters, and your foundation. You edit your allowable stress, that's the bearing capacity. In our case we'll be using 120. Then for soil vertical subgrade coefficient, you choose the lowest, lower limits. Okay, edit materials. For your concrete columns, select on, select all, use Y12 and Y16 for our columns. Concrete walls, we are not using concrete wall. Then concrete beam, we use Y12, 16 and 20. Then our slabs, select on, select all, use Y10. Then go to our links. Our links is Y10. So we'll go to our foundation level, select on, select all, use Y16 for our foundation. That's for our footings. Then our links still remain, our link still remains Y10. Click OK. Then loading generator. OK. Load case. OK. Then you close. Then you go to your modeling again. Your slab strip. The x-axis. Click. The x-axis. So you now change it to y-axis. To avoid too much of detailing, you can actually start from there and stop here. If you want, you can run it all through, but the reinforcement that will actually be here is the same as the one here. Now let's go back to analysis and edit our slab. Y12. Okay. So you are done with your slab. When you are done with your slab strip, the next thing you do is to insert your stories. And click on story. Click on insert story. And we have just a story, just one suspended floor. So for Prota, you insert 2. When you have 2 suspended floor, you insert 3. Continue. Yes. Go back to your level 1. Click on story. You now edit your story. So our level story 1, we have 3,450. Actually, the description, that's the ground floor, and this is 3,450. Say first floor. Then you assume your roof has normal story. Your foundation depth, let's say 1,400. Click OK. So what you're going to do next is to generate our story. So we'll generate to this level. We'll not generate our slab. We'll not generate our like this. You can check them. So you have just bean, columns, bean, braces. You click OK. Process completed. So you close. So let's see whether what we have, some of these columns are going up to our roof level. So by doing that, you can go back to your AutoCAD file, highlight this one, W again. You can still save it as last one A. This is the X file, save, single limiter. Go back to your Prota, which is building, set out with external reference. You now add so this is what you need now. So you can see it's now added. Now in a situation where you try to import this and you discover that they are not on a straight line, you can just click on move. So now click on move. So assuming you don't have this in line with your structure, you can just click on move. You can click on move maybe at the staircase level to join it where it is. But in this case, now the building we just imported have aligned with our existing model. So you just click, just escape, and everything still remains this way. So you can see that the columns are in line with the walls. We don't have cantilever, we don't have anything. So this process can actually help you when you have multiple floors. So in our next video, we'll actually be creating multiple floors, working on 2 or 3 stories, so that we begin to import our DSF files at different levels in order to guide us on where to insert our columns and where to insert our beams. So at our roof level, you can actually edit your beam. Let's edit our wall, unit wall load for our beam. Click on it, edit our unit wall load. You actually divide this, you take half of it, which is 1.5. Then I copy this one, Ctrl V, paste. So if I now click on any of the column, you see that it's 1.5. So the next thing we do is to run our analysis, building analysis. Go to analysis, building check. Always check your building. If there are errors, you have identified. So in our case, we have 0 errors. So we can now proceed to the analysis. We select, we do the analysis. So our relative stiffness both in the x and y axis are okay. So close. So let's check our displacement before we go to our post analysis. So we have a lot of displacement here at our beams. We don't have issue with our column. So we can actually increase the depth of the beam. So let's cancel it. Let's go to building analysis. Let's go to post analysis. So we don't have issue with our columns. Let's check our beam. With our beam too, we don't have issue, but we can actually increase the stiffness.